Welcome back to Munro Live. Well, we're continuing with the teardown of the Chinese Skywell. Again, a vehicle that's been here for 3 years, but we're finally getting to it and tearing in to see how they were able to achieve a vehicle that would sell in the $30,000 price range. Now for me, I've been looking at the seats. I have completed my teardown of the seats. I am not taking down the passenger seat since it's mostly a reflection of the driver's seat. And looking through my program, everything that I have done, it appears that I have roughly 2,500 either materials or steps that I've accounted for in costs for this vehicle. So in that, again, is not inclusive of the teardown of the passenger seat. I will double up some of my driver's seat components and costs to come up to my total roll-up cost for the seats for this vehicle. But what I wanted to do today was go through some of the things that I've noticed as I've torn down this Skywell and give you not really my impression, but the things that I look for and the things that I really notice. When we're doing a teardown like this, the question is, well, who does it benefit? Sometimes we'll have a customer that will buy a report and they'll use this information in whatever they do internally. Sometimes a customer will come to me and say, do you have any ideas to help us design something more efficiently? We take that what we have learned from all of these different vehicles and say, here's the good, here's the bad. Here's the trade-off for this type of decision. So I wanted to show you some that I've seen. Now the first thing that I want to talk about is the rear seat cushion. You'll remember that when we did the review of the Skywell interior, I could not fully fold flat the rear seat back. We did notice that there was a function to the cushion. The rear seat cushion would actually completely lift up and then stand up on its end. Here are the hinge components for that cushion. Now it was very, very shaky, and from side to side it would somewhat kind of lock up on itself. But in order to enable this, there's an increased structure inside of this foam, slightly higher gauge metal than what would normally be necessary. And there are these two brackets, one on each side. These brackets have to get bolted to the structure that is included in the poured foam. That gives you your hinge, which these two are almost exactly the same. They are actually handed because of this wire is on opposite sides, meaning that now I have a poka-yoke issue in my plant. I have to remember which one goes on which side. But there's really not any marking that would tell you which is which, so you just have to know. That is something that we don't normally like in production. We always want some sort of a feature that helps us to quickly identify something that would prevent me from bolting this in the wrong location. And in this design, there's nothing that's preventing me from doing that, so this would be a problem for assembly. First thing that I like to do is I like to tear apart a seat. I like to try and take the back off of the cushion frame. The way I do that is I take off the plastics, I look for whichever electrical connection needs to be undone, I unbolt the seat back, and then completely separate the trimmed out cushion from the trimmed out back. You can do that on this seat. There are 2 bolts on each side that connect the seat back to the seat cushion, and you'll find that there's only 2 wire harnesses that go between the two. The wire harnesses easily separate. Most of the OEMs I deal with have that type of a construction. However, there are a few, Honda is one in particular, where you cannot trim out that seat because all of the electrical is integrated into itself. So you have to build all of the internal structure with the seat assembled. I have to put on the foam, and then I have to put on the seat covers in its assembled condition. Depending on how you do the full assembly, it doesn't really matter. However, it limits some of your options in the future because I have to be able to tuck the lower flap of foam in here with the cushion foam already in place. I have to be able to push the cover stock through here with the cushion foam already in place on the Honda vehicle. So I like the way they did it here. However, they have a couple of problems. What I would do after that is I would take the back and I would take the cover off. To take the cover off, normally there would either be a back panel. You'd remove the back panel, then you can unhook all of the cover. Or there's a pair of zippers on either side. Unzip it, flap out of the way, and then start unhooking it. However, for this vehicle, this is something that has been done in the past that I have not actually seen in a while. There is no zipper. There is no back panel. I sliced this with a razor knife to be able to get in there and undo the hog rings. So how did they do it? After they sewed this entire cover, they flip the cover completely inside out. So now I have an inside out sleeve. It gets presented to the seat back in the plant, and then this sleeve unfolds on itself as you pull the sleeve down the seat back. But all of these points are points where I have to make some sort of an attachment or a connection. So as this inverted sleeve slides down the seat back, I have to put all of my hog rings in all of these positions as I'm going down. That makes your initial alignment at the top critical, because I have a line of hog rings that attach here, and I have a line of hog rings that attach in the back. If I'm off a little bit on my pull down of the sleeve, this could be off by 3/4 of an inch. It's not going to line up properly. I would have to redo it. This is labor intensive, and what it is impossible for service in the future. Let's say you have a damaged bolster from getting in and out of your vehicle, and you want to go to some sort of an aftermarket trim shop, and you try to say to them, oh, it's just this one little piece. Can you sew in a new piece? Yeah, take the cover off. Taking the cover off is going to be more work than sewing in that little piece. So that's when you think, oh, it should be a $50 to $100 repair. No, it's $1,000 because of all the work that it takes to take that cover off. Or they'll tell you, no, just get a new seat because I don't want to do that. So that is an issue. It's something that I really don't like. I don't like that system. They should have just done a zipper, which they did on the second row. If they had zippers on the second row, why did they avoid using them on the first? That's one thing that I just don't really understand. Okay, so we've talked about that. Let's get back to this structure. Now, I don't like the second row structure. I'm saying that it's not efficient. They have very high gauge of steel. Okay, but the front row structure is very efficient. And this is normally where all of the engineering time is spent, because if I'm building a vehicle, I will always have a front row seat. However, for the second row seat, I may not always have a full down seat. I may not always have a bench seat. I may have a center seat. So really, if I put all of my effort in here making this very, very efficient, as long as I get a seat for the second row that meets requirements and works, it gets built and shipped. They don't put any more effort into it. So this one right here, I count all of the metal stampings that are in this assembly. And then I also count all of the assembly operations, the types of welds that are required. There are relatively few stampings in this, even compared to Ford, and especially compared to Honda. On this seat structure, this is half the amount of stampings that Honda would have. Now, it's not just the stamped components. Think about it. These components are attached with rivets. So if I have twice the amount of linkages, that means I have twice the amount of riveting operations. So I like how efficient this seat is. Now, the one thing this seat does not have, it's an adjustable front. Lots of times you'll have a tilt motor here that kind of lifts the pan. This pan you'll see is welded solid to the side rails. So the Ford, which is still an efficient structure, has an adjustable pan. It's not always used. Some vehicles don't have that option, but yet the adjustable pan still goes along for the ride. This is a completely welded fixed pan. This is the luxury feature that they give you. This is basically a calf support. Bolts up into the structure and gives you some support to the back of your legs. This is another one of those features that as long as it works, they build it and ship it. They don't put a lot of effort into it. They don't put a lot of thought into making it lightweight, making it efficient, because not every vehicle is going to have this. What surprises me is they didn't even paint it. Now, as I've talked to some of my different Asian customers, they've explained to me that for their market, having painted structures within the instrument panel, in the seats, is very important. Especially, they said, for aftermarket. When people go to sell their cars, some people will try and knock off of a price just if they can see any exposed metal that is not painted. I'm like, okay, I guess I understand that. However, for me, I suspect that there's also an issue with poor quality steel. There was one vehicle that I torn down from one of the Asian startup OEMs. Not only were they were painted twice. So they had a gray primer layer, then they had a black paint over top of that. And there was one section on the seat back that the rust was actually flaking all the paint off in large chunks. I'm like, okay, if you painted it twice and you still have flaking paint and this vehicle is less than 6 months old, then the metal that was being inputted was probably in a bad state. And I have to say the same thing here. I have vehicle seat structures here that have been here for years that are not rusting at all. This has been here for 3 years. It's never really even been driven. It's not road legal for the US, but the amount of rust that I'm seeing on that assembly makes me question the steel quality that they have going into their plant. All right, the positive on the seat tracks. The right-hand track and the left-hand track is the exact same part number. It is literally the same component from right to left. This is the drive gear. The drive gear is open on both sides so that from one side or the other, it can drive forward and back. These brackets, this is what makes it unique between right and left. Here's the problem. If this was a Ford seat track, this track would not be common right to left. And the reason why it would not be common is because this bracket would be welded to this assembly, and that would make it unique from one side to the other. This one bolts to the assembly. So here's the question. This is now a loose secondary component that's going into final assembly that has to be riv nut, then threaded fastener, and then a pair of threaded fasteners. Is the operations of using these fasteners, does that negate any cost savings from having a common component from right to left? So let's say I did not have this be a common component and I had this bracket welded. Now I have to inventory 2 separate components on my shelf for those tracks. I have to manage them. They have to be matched pairs going into the vehicles. Is all of that effort, is it worth it to eliminate those bolts? And that actually depends on the plant, and it also depends on the bracket. The brackets on the Ford, because lots of times they'll have a dip in the floor, one side is higher than the other, so they're very unique. These are fairly common from right to left, so I kind of like the simplicity. Looking at the seat back, when I talk about the efficiency, all right, very, very lightweight frame, and then this is just a bent tube, where I would have a full stamping on most vehicles going from side to side. That stamping would then support the headrest guides. Now what it would do is it would make a C channel in the stamping. That C channel would have an opening at the top, opening at the bottom, and that's what's supporting the headrest guides. Because this is a tube, they have to weld on secondary tubes, which are my headrest guide supports. The angle of those tubes are important. The position of those tubes are important. So here's the question. If I'm managing the assembly of these 2 tubes, the position and the angle of those tubes, is that more time consuming and more costly than having a larger stamping tool that would stamp this all out in one piece? Now that stamping tool would have multiple processes because you'd have piercing on the top, piercing on the bottom, folding, you'd have its own internal tolerances. But these are all the little things that you need to calculate if you really want to understand what my total efficiency is. This frame and this motor is my fore-aft motor. This attaches to the seat tracks, and that is what actually slides my seat front to back. Now I've had discussions with some of my customers on what the most efficient bracket is here. I prefer a stamped steel bracket like we see here. Some of my customers do these large injection molded plastic brackets. They make them out of nylon. They make them really, really tough. And I talked to one of my customers and said, why are you making that thing so rigid? And they said, well, we actually had a problem where there was a water bottle that rolled underneath the seat. And as someone was trying to cycle the seat, the water bottle got caught on the transfer motor and it broke it. Okay, but the steel is still stronger than all of that injection molded plastic. My question is, are you just designing your steel wrong? And for this one, they did. Look at this point right here. We have a bend. At that bend, the sidewall is thinned down. Not only is the sidewall thinned down at that bend, but then we have this hole that they've cut out into it. So we have this narrow section of relatively flat steel on both sides that are right at the drive cable for this. Now the problem with that, if I can relatively easy bend it that much, then if that is underneath my seat and something is stuck under there, yes, that is going to bend. Putting that hole and having that type of sidewall is wrong. You can just change your stamping formation, change your blank formation, and strengthen this bracket. A stamped bracket is less expensive than an injection molded plastic component. So I would keep the metal, but I would design it right. Let's take a quick look at these headrests. This is a second row headrest. Now you'll notice that this does not open. Basically, this seam of the headrest is glued shut. Okay, so what is this hole? They made the cover, they took the metal rods, they inserted the metal assembly, glued the seam shut, and then they inject the foam that completely fills this cover. That injected foam glues it all together, so I cannot open this. Again, it makes service a problem later on if you want to cut this open, make a new cover, change it out, but who services their headrests? I don't have a problem with that. I like that foam aspect. However, this is the front seat headrest. Now you'll notice the two layers here. This gives you the look that I have an adjustable headrest, which we have seen on some of our high-end vehicles. But this is all sewn together. This is still one piece, and there's the injection point. This is one big block of foam that is giving you the impression that is an adjustable headrest. All I have to do is change this shape to support the headrest in the exact same position. But the amount of sewing that they did to make this look like it was a secondary component, that's expensive. So I'm still going through and finalizing all of the final costs that I'm assuming for the assembly of this vehicle. It's actually coming in pretty decently, I think, from the costs. I have to verify that all my costs are working well with the Chinese market, since this would be Chinese labor, my material cost rates, the labor rates, the power consumption rates, all of that stuff goes into the calculation. So we do that across the globe. Sometimes a customer will come to us and they'll say, I want to design this part, how do I make this part better? And I have to ask, well, where are you building this part? Here in the US, we actually have good rates for utilities, gas costs and power costs. Our labor rates, however, are higher. If I have a process that is highly automated, that requires expensive machinery and expensive electricity, I may actually prefer to have that done in the US. But if I have a process that is very, very manual labor, but yet does not require any specialized power consuming equipment, well, then I may want to move that to a low cost country. It all depends. All of that stuff has to go into the calculation. And I can say, well, if this is my current design and I want to build it in this market, or I want to sell it in this market, is there a way that I can change my processing steps or my design to enable me to make it in this market or that? And the answer is yes. We can do that calculation, and we can work through what is the most efficient process, what is for the place that you would like to build. I've actually pulled some product out of low-cost countries and moved them back into the US just with some simple redesigns that enable us to automate processes, that enabled us to actually save cycle time, which then saves on labor rates, even though the power consumption rate would be higher. But also ends up reducing logistics because I'm not shipping the parts as far. And also it protects against any type of taxes or import tariffs coming from one country to the other. All of those things go into the calculation, and all of those things are a benefit that Munro can help our customers with, help them to really understand how they can both design their product, how they can manufacture their product, and where they can manufacture their product to the top price point that they are looking for. So I hope you've enjoyed this small little review. Please stay tuned for any future videos from the Skywell and the other components that we will be tearing down.